We are going to solve right triangles in this section by means of application problems. We are going to do several examples, so you are going to get lots of practice. In example 1, a tunnel is to be built from point A to point B. Both A and B are visible from point C. If the length of line segment AC is 1.4923 miles and the length of line segment BC is 1.0837 miles, and if C is 90 degrees, find the measures of angles A and B. Round to the nearest thousandth as needed. All right, luckily, a sketch of this situation has been provided to us. It is key while working word problems that you have a sketch. If one is not provided for you, you need to draw one. The sketch or illustration is key to the solution process. Okay, so let's take a look at what we have here. A lot of the information that is given in the problem is shown in this illustration. So to start off here, you see the points A, B, and C. We know that C is a 90-degree angle, and that is indicated by the little square here that we are dealing with a 90-degree angle. We are told that the length of AC is 1.4923 miles. That is labeled right here. So that's the length of this line segment from A to C. And then we also know that BC is 1.0837 miles. And that's this line segment over here. It is also labeled for us. And what we need to do in this problem is find the measures of angles A, which is this angle, and B. Okay, they may look very close in measure, but we cannot assume that they are the same measure. So we're going to have to solve for each one separately. Okay, so that is what we are doing in this problem. So when you look at this, this is a right triangle as indicated by the right angle. The tunnel kind of covers up one of the sides of the triangle. So I'm going to go ahead and mark over this. I'm going to redraw a line segment from A to B so we can more clearly see the hypotenuse. This is the hypotenuse of the triangle right here. Okay. All right, so let's get started here. It doesn't matter which angle we start with. I'm just going to start with A, okay? To find A, since this is a right triangle, we are just going to set up some kind of right triangle ratio based on the information that we have, okay? If we look at angle A, let's label things relative to A. So if I go straight across from angle A, this side is going to be opposite A. Okay, we already know the hypotenuse, that cannot change. So that means relative to A, this other side, AC, is the adjacent side. So now that we have all three sides labeled, in terms of adjacent, opposite, and hypotenuse, relative to angle A, we can set up a ratio, okay? Now, we know the opposite side's length and we know the adjacent side's length. So since we know opposite and adjacent, we should use tangent here. Now, it is plausible that you can use the adjacent side and the opposite side and plug those guys into the Pythagorean theorem to solve for the hypotenuse and then come up with some other trigonometric ratio to solve for A. That's perfectly fine. It's just more work, okay? If you go with tangent, you can use the given information and you don't have to do any additional work. Okay, so here we go. If I want to find angle A, I'm going to say that the tangent of A, that is going to be the opposite side over the adjacent side. So the side opposite has length 1.0837 miles. The adjacent side has length 1.4923 miles. Okay, so that is going to be my ratio. And now I can solve for A. All right, So you've got two decimals here and you can go ahead and divide them. You're going to end up with a nasty decimal. So my recommendation is to just plug this into the calculator all at once. Okay, so make sure you carry all your digits, okay, for accuracy. So I wouldn't bother here. I would just punch it in all at one time. Okay, so we have the tangent of A is equal to this fraction. We want A, but A is trapped by the tangent. Okay, so what undoes tangent? Well, tangent inverse. Okay, so I'm going to go ahead and take the tangent inverse of both sides. Okay, whatever you do to one side, you have to do to the other. Okay, so this is what we're going to get. We're going to get the tangent inverse of tangent A. That is equal to the tangent inverse of 1.0837 divided by 1.4923. Okay. On the left side, tangent inverse and tangent cancel, and that is going to leave you with angle A. Okay, so all we have to do is go to our calculator and punch in tangent inverse of 1.0837 divided by 1.4923, and that will give us the measure of angle A. And according to the directions, we are going to round to the nearest thousandth as needed. Okay, now remember, we're solving for an angle. When you go to your calculator, it depends on how your calculator is set as to the type of angle you're going to get out. If your calculator is set to radians, the angle is going to be spit out in radians. If your angle is set to degrees, your angle is going to be spit out as degrees. Okay, we interpret degrees way better than we do radians, so just make sure your calculator is set to degrees. Okay, so I'm going to go to my calculator here. I'm in radian mode, so I'm going to go ahead and switch over to degree mode because that's a lot easier to interpret. And then I'm going to do the tangent inverse of, let's see what we had here, 1.0837. And I'm going to divide that by the other number, 1.4923. Close my parentheses, and then here we go. This is going to be my angle. Okay, so I will go ahead and write down this entire decimal expansion and then I will round it. Okay, so 35.98, let's see, this is going to be 35.986945. 6945, I believe it was 27, yes. And this is measured in degrees, okay? We need to round to the nearest thousandth, like I said, okay? If you remember how this works, if you look at the decimal point, this is tenths, hundredths, thousandths, okay? So we need to round to basically 3 places after the decimal point, okay? So what we see here is that there is a 9 after the 6 here. Okay, so this 9 is going to bump up the 6 to a 7. So this will round to 35.987 degrees. That is the measure of angle A. Okay, I will go ahead and write it up here. This is an approximation because we had to round. So I'm going to say angle A is approximately 35.987 degrees. Okay. All right. We still need to get angle B. Okay. So you can totally go ahead and set up a trig ratio. Okay. Right triangle ratio for angle B, just like we did for angle A. However, you don't have to. Okay. So remember this. Okay. Every triangle, well, I'll put it this way. In every triangle, right or not, the sum of the angles is 180 degrees. Okay, every single triangle, right or not, the angles add up to 180 degrees. Okay, so we know angle A and we know angle C, so we can just subtract from 180 to get the measure of angle B. Okay, I'll put this in a different color. So to get angle B, we're going to take 180 total degrees in one triangle. We're going to subtract out the 90-degree angle, which is going to leave us with 90 degrees. Then we're going to subtract out angle A. So we're going to take away 35.987 0.987 degrees. Okay, this will give us an estimate for angle B. Okay, so I'm going to go back to my calculator. I'm going to do 90 degrees. I'm going to subtract out angle A here, and this is going to give me the measure of angle B. Okay, I need to round this to the nearest thousandth as well. So we have 0.013. So that's 3 places after the decimal point. There's a 0 after the 3. So the 3 will stay a 3. It will not bump up to a 4. Okay, so this is going to be 54.013 degrees. Okay, that is the measure of angle B. I will put that right here. And again, this is an approximation because we had to round. Okay, so B is approximately 54.013 degrees. And we are done. We have found the measures of both angles A and B.